In notes 6.4, part 3, example 5, we're going to graph translations of sine and cosine. Remember, when you're graphing sine and cosine, usually you want to show at least one cycle. In our examples, we're going to graph 2 cycles, and in each cycle you have to show 5 key points. All right, we're going to begin with the graph of f of x equals sine of x plus 1. So going back to our understanding of transformations, this plus 1 outside the function is a vertical shift up 1 unit. So that means you add 1 to y values. So we will first graph the parent. So the parent function is y equals sine x, and then we will shift it up 1 unit. So when graphing sine, I'm going to put a scale on this on the y-axis. I'm going to do 2 units, two lines, 2 squares is 1 unit. So I'll put that on there. And when we're graphing sine, it starts at the origin. So it starts at 0, 0. And then we have a key point every quarter period, which on a parent function is every pi over 2, because the period is 2 pi. So we're going to start at 0, 0. Sine is going up as we go from left to right. From 0, 0, it goes to maximum, so pi over 2, 1. Then it's going to come back to the midline, pi 0. Then 3 pi over 2, negative 1. 2 pi 0. 5 pi over 2, 1. Next quarter period, 3 pi 0, back at the midline. And we can go to the negative x values, so negative pi over 2, negative 1, and negative pi 0. I'm going to sketch in the parent function. I'm going to use a dashed line, because that's not really the graph we want to be doing. So this is y equals sine x. And then the true graph we want to do is y equals sine x plus 1. I'll do that in red. And all we're going to do is we're going to shift all these points up 1 unit. So 0, 0 becomes 0, 1. Pi over 2, 1 becomes pi over 2, 2. Pi 0 becomes pi 1. 3 pi over 2, negative 1 becomes 3 pi over 2, 0. 2 pi 0 becomes 2 pi 1. 5 pi over 2, 1 becomes 5 pi comma 2. And 3 pi 0 becomes 3 pi 1. And I'll do the last 2, just shifting them up 1 unit. And then we'll graph our function, y equals sine x plus 1. Put arrows on the ends because the graph continues. So this is f of x equals sine of x plus 1. In terms of the characteristics, the domain is all real numbers. The range, now that has actually shifted. So the range is going from 0 now to 2. So we have shifted the graph up 1. The previous range was negative 1 to 1. It's shifted up 1. The range is going to be 0 to 2. The amplitude is the distance from the midline. So the midline now is at y equals 1. So the amplitude is the distance from the midline to the maximum. So the distance from 1 to 2 is 1. You could also think the distance from the midline to the minimum. So from 1 to 0 is 1 unit. Or half the distance between the minimum, 0, and the maximum, 2, which would be half of 2, which is 1. So the amplitude is going to be 1. Oh, I skipped the period. The period is 2 pi over b. b in this case is 1. So the period is 2 pi. We have not changed the amplitude nor the period with just a shift up. And the transformation was a vertical shift up 1 unit. Okay, next graph that we're going to do, example 5b. We're going to graph y equals cosine of x plus pi over 2. We will begin with the parent function. I'm going to put a scale on my x's, so I'll do 2 squares again is 1 unit. And we'll graph the parent, which is y equals cosine x. And let's think a little bit about the transformation. When we have x plus pi over 2 inside our function, that affects x values. So this transformation is left pi over 2. Remember, whatever happens to the x is actually the inverse of what we see. So if we're adding pi over 2 to x, the transformation is actually left pi over 2 units. All right, so let's graph the parent function for cosine. Cosine starts at the maximum, so it's going to start at 0, 1. Then every quarter period, we have a key point. So it goes from a maximum to the midline, so pi over 2, 0. Pi negative 1, 3 pi over 2, 0, 2 pi 1, 5 pi over 2, 0. 3 pi negative 1, negative pi over 2, 0, negative pi negative 1. So you can follow the pattern. And then I'm going to sketch in the parent function, y equals cosine x. Make sure that you put arrows at the end. And here, make sure that this arrow turns up and doesn't shoot down. That would be outside the range of the function. All right, now we're going to do the transformation. So we're going to take all points and move them left pi over 2. So 0, 1 is going to become negative pi over 2, 1. Pi over 2, 0 will become 0, 0. Pi negative 1 becomes pi over 2, negative 1. And once you have a few points, you don't need to shift them anymore. You can just graph the cosine function knowing that we get a key point every quarter period. So now I'm going to graph this function, which is f of x equals cosine of x plus pi over 2. And if you look at this graph, it's actually a graph of sine of x reflected in the x-axis as well. Okay, so the domain is all real numbers, negative infinity to infinity. The range is negative 1 to 1. We haven't changed that with the shift. The period also doesn't change with the shift. It's still 2 pi, the same as the parent function, or you can think of it as 2 pi over b. B in this case would be 1. That's the coefficient in front of cosine. The amplitude is the distance from the midline, which is y equals 0, to the maximum, which is 1. So the amplitude is still 1. We have not changed that by shifting the graph left 1 unit.